Hi, this is Anita Wood, and this topic snippet is going to be for Module 6, which is arrays, and we're going to do a basic introduction and searching, parallel, and just an introduction to 2D arrays. So let's get started. Before we get started, I want to just kind of remind us of where we were with variables and how we access them and where they were located in memory. So we had this, and we've saw this before. This is memory for us, okay? We have addresses in memory, and that is the actual location it is inside the memory, um, even the card, okay? But what we're more concerned about is we have a variable name, and that ends up, that variable name is pointing to a part in memory that contains the actual value. Okay, so I have 3 employees that I want to keep track of. And right now I have 3 different variables, 1, 2, 3, employee 1, employee 2, employee 3, and they point to different strings for the employees' names, okay? So that's generally what we would have done. If I said, let's just keep the employee, names of the different employees in my company, as of now, the only thing we would have been able to do was have an individual variable for each employee. Well, that kind of gets us in trouble because we don't know how many employees we have. And as we add, we have to keep adding and creating new variables with the next number. So if I needed one more, I would have had to sit there and create another variable, declare it and such, and put in here the next employee's name. That is real haphazard by the philosophy of programming, because in programming, remember, we're always looking for patterns. This is a pretty good pattern going on here, that we have something that's the same type of data. These are all strings. Not only are they just strings, they represent employee names, so they're related in that aspect. They have something in common. And it would be nice if we could tell the programming language that we would like to have all of these employees' names clustered together in an array. And that's what we are going to do. We're going to cluster them, and the name of what we're using for our new term is an array. So what we want to do is we have data that's related. We have an employee's name. They're all the names of the employees, and they're all the same data type. This is really crucial for us. Same type of data. Okay, so they all have to be strings, they all have to be numbers. They can't be a mix in our philosophy right now. So what we were doing is we'd have a variable, ename1, and I would store Anita in it, ename2, I'd store James, ename3, and I'd store Anna. But this is really inefficient. We don't know how many we have, and it's harder for us to process them. Because what we'll see when we're searching arrays, the processing is when we really get the value of where the array comes from. So right now, it may look like, well, you still have to, point to the different places, but we'll see in processing where the value starts. A few things we really want to come to terms with is what we are doing for the declaration and how do we access or point to the different parts of the array, the different locations. So we are going to say we have a name, ename, an array. It's going to be called that, and it's going to contain the 3 elements. I'm going to put them all inside there. So first thing I want to do is I'm going to declare a constant. Notice that they're all caps. And the constant has a value of 3 because that's how many values I currently need to store. Then I'm going to have another declaration. I say what type of information, a type of data is going to be inside my array. Here is my array name, ename. And then notice I use square brackets, and between the square brackets I say how many elements How many different, items do I want to store inside the array? And right now it's 3. You could put the number here as 3. All right, that works the same way. But we're trying to add some flexibility. And if you use array size, we would be able to initialize it up here and constantly just worry about that versus getting into here, which might start showing up like a magic number. So now I have the array, I've declared it. Now I want to initialize it. And to initialize it, I use the name of the array, square bracket, and what this is right here, this is the pointer to the location in the array. Okay, this is the pointer, this is the location, this is the subscript, this is the index. All of those are terminologies that are used to say, I want to get a hold of the first location in my array, and I want to put the name Anita in it. Now, what you see here is it starts at 0, even though I said first location. Always start subscripts or indexes at 0. That is just a common practice concept that is going to be necessary for all of our languages, no matter whether we do C#, Java, Python. You always start the location at 0 because this is the first location inside the array, and it's going to contain Anita. Now the second location is actually indexed at 1, is going to contain James, and the third location, the third employee's name, is Anna, and it goes in location 2. All right. This is the most difficult part of understanding arrays, the fact that we start indexing them at 0, and the index 0, the subscript 0, actually points to the first location. That continues, that little difficulty continues when we're trying to figure out how big the array is and how many locations are in the array. So what happens here is I end up needing to point to a particular location. So if I have the array size and I want to get to location 0, the first location, all right, I end up, the array size is 3. I'll put the number right in there. And so it's 3 minus 1. This is always needs to be in here. The size minus 1 is actually the location I want. Okay, so this, put this back, would point to location, the last location. Oops, I made a mistake here, didn't I? That should be Anna. I can't spell. That's the last location. Okay, so the size is 3, and the actual location of the third one is 2. Okay, so the subscript for the last element is always 1 less than the array size. These are just, I put them in red. I try to get them to, be something that is annoying enough that you won't forget. And I'm going to say it one more time. You always start the subscripts or indexes at 0 if I want the first location. To get to the last location, I'm always going to be 1 less than the array size. Okay? Right here, that's the last location in my array. It's 1 less than the array size. So let's look at this one more time using our little grid. I have a declaration here for an array called eNames. It is of size 3. I want 3 places, 3 slots, 3 elements. I'm trying to come up with all kinds of names for you that I want to hold information for. So then here is the way I access this cell. This is the first element in my array. I subscript it. Notice I try to point and say these are all subscripts with 0. If I want to get to the second element in my array, I subscript the array name with 1. I want to get to the third element in my array. I subscript the array name with 2. Okay? So if I go and I say ename, which is the array name, and I have subscript 0, what I'm actually saying is this ends up translating to the value that resides in the first or the 0th location. Put location, that's a better word, in the array. Okay? And what that actually is e name subscripted 0 is going to get me Anita. Hopefully that helps you a little bit. And what we'll do is we're going to actually use this array and these rules that you see here, subscript starting at 0, the last location, the last element in the array is always 1 less than the array size. So let's start trying to figure that out. We're going to use one of those debug exercises that comes with the textbook. And what we're trying to do, I'm going to read the problem statement to you. We want to accept the student's year in school. So the student's year in school is 1, 2, 3, 4. So they're representing freshmen with the number 1, sophomore with the number 2, juniors with the number 3, and seniors with the number 4. So what we want to do is we want to take the year in school that that particular student was, and then also the number of cans they collected. Okay, they have a recycling drive and they want to collect all of the different students, say what year they are and how many cans were collected. Because what we want to do is provide an output that says the year 1, 2, 3, 4, and what was the total number of cans collected by everybody in that class. So we'll read a student. They tell us what class they're in, which is which year they're in. And then they're also going to give us the number of cans. So we're going to continuously read and then calculate and accumulate the number of cans for each year. So that was the information. Okay, that was the problem set. So let's look at this. This was the debug. And there's issues in here, and we're going to clean them up together. So this defines the same situation that I told you previously. So let's look at what's going on. So we're going to end up, let's just ignore the declarations for a minute and get to the meat. That's one way to look at a debug situation, because we're not sure what these are going to be used for until we start looking at the logic. We have the logic here. This logic is inputting and accumulating the total cans by year. Okay. So here we're going to go and the input was set. You're going to get the year that the student is and how many cans. So then we're going to take that, and this helps. I'm going to write this down here. I'm priming the loop. Okay. All right. I got to prime the loop. And I'm going to try to read from a file. And I know that because of the loop control is end of file. So loop control is end of file. When I reach the end of the file, then I know that I have no more records to read, but I have to read that first one to at least get started and prime the loop. So while I'm not at the end of the file, I am going to, let's see, what I want to do here is use an accumulator. All right, I'm going to accumulate the number of cans for that year. And what it looks like they're doing is they're using an array for the accumulator. And then each element in the array is going to represent a year. Okay, so if that's the case, let's look up here. Right here is where they are declaring and initializing the array. They use the variable size, which is 4, which is good. So now we have this one understood. This is the size of the array holding the number of cans collected for each year. All right. And now I'm going to go over here and snag some comments that help this. So here's my accumulator. All right. So it's accumulating the number of cans collected for a group of students, and the grouping is by the year. So when I say that, I give you a little bit more information. Collected with the subscript of 0 is the number of cans that were collected for the year 1 students. Okay? Collected with the subscript of 1 is going to be the number of cans for the year 2 students. You see my pattern, collected 3, 2, for year 3, collected 3. Notice this is one off. The year and the subscript is off by 1 because I start my subscripts at 0. I don't have a year 0, I have a year 1. So we'll put year 1 in at subscript 0. Keep that in mind as we go through the debugger. So I've initialized the array. This is how you can initialize an array. I declare it with the size, and then I put the values, comma delimited, for the different elements. This has 3 elements, 3 values, but my array is 4. So it means I'm missing initializing for collected 3. All right. Do this up against, this would have gone in collected 0. It would have initialized it to 0. This is collected. This is for year 2. It gets in collected 1. You see the confusion? You just got to keep these straight. And quite honestly, writing them out like this is probably the best thing you can do for yourself. Make sure you've got it. And then this one would have been initializing collected for year 3, which is subscript by 2. This is initializing year 4, which is subscript by year 3. So you just line them all up, comma delimited. That's how we can initialize an array. So we got that set, so we found one of the problems. All right, so we keep going down in here. We now need to figure out if what's happening in our loop. We have a year and the number of cans. Okay, so what we want to do is they want to use the year for the subscript for this. Okay, to subscript the array in which I'm using. So it's a nice little shortcut. But let's think about this. If I use the year, let's put what came in was year 2, and they collected 10 cans, okay? So this is what we're going to do for the pretend input. 2 is the year and 10 is collected. So what I've got is I want to set up collected, my accumulator, for year 2, right? So I put the year in there, and let's look at what the subscript for year 2 students should look like. It needs to look like 1. It needs to be 1 less than the year, isn't it? Here's the year, here's the subscript. Here's the year, 1 less than the year is the subscript. So this isn't going to really work. This isn't going to put it in the exact location I want it. I want to save it in year minus 1. Because I got the year 2, and it needs year 2's go in collected subscript 1. Okay? Now here I'm doing my accumulation. I'm taking what was previously in that location, and I'm adding the new number of cans to it. So let's make sure we're in good shape. Previously, for this location, I had 0. So I'm going to add 10 cans to this area in the array. All right? So I want to do one more little piece of snag. All right? And I'm going to move this over here. Give some more comments. That the subscript for the array is 1 less than the year of the student. Okay? We've been working with that. Nothing we can do about it other than accept it as a fact and deal with it. Now, I'm ready. I'm done. I need another record to deal with. So really, when I'm adding comments, this is updating a loop control variable, right? Because I'm going to go and try to do another record. If there's no record, EOF equals true. All right. If there's no records to be found, if I have no more records here, I'm going to get an end of file equals true. So now I'm going to spin back up here. And as long as I'm not at the end of the file, I'm going to read another year. I'm going to read another year. So let's do 4 and say they did 20. Okay. So the year is 4 and the number of cans is 20. So year being 4 means it's going to collect, it's going to be subscripted at the index location of 3. So 4 minus 3 is 3. And then I'm going to end up placing it in here. Okay? So cool. That's all done. Let's go down. These are the headers. That's what they have here, because what they do in this book frequently is a really good practice. So if you haven't thought about it, when I have to go and put headings out, and the headings don't change, I could put them in a constant and just place the string that I want printed here. And what's really nice is, say I did a typo, which I do it all the time. Okay, I could easily fix the typo here, knowing that I have collected, which dyslexic would do that. Okay, I would see the output, and then I'd have to go in my code and go somewhere down in here and find it. But it would be right up here, very easy to fix. So what they're outputting are just the can recycling report header and the labels for the rows, the headings for the rows, the year and the cans collect. That's all that this is doing here. So let's give a little space and say, okay, now what's going on here? This is where we are printing the array or the cans collected by the year. Okay, so let's see what we got going. As we know, we need to always, when we start a loop, we need to prime the loop. So I'm going to assume this is prime. I'm priming the loop with the loop variable. Okay, we're going to use year. And I'm going to spell better. Let's add a little bit of space here so I can see. So if I start at the year 1, which is our year, that's okay. We just have to remember what's going on. Now I'm priming my loop. So this is my test for the loop. I want to stop the loop, all right? And I have to figure out when to stop the loop. All right, so let me do a little bit more information here that we know about. There's the prime. But if I'm going to use that prime, it looks like I've also used it as the subscript. And I want to make sure I've got this set up right. So year, if I go through and I want to output the year here, and I want to keep doing it for all 4 years, the subscript is 0 through 3, okay? But when am I going to stop? I only have 4 years. I got to get that from here, right? Or size 4, that's the number of years. So if I say while year is less than or equal to year, am I going to ever end? Because isn't year always going to be 1? That's not a good test. So let's say we know we have 4 years and we have a constant that's already sitting here as size. So let's use that. I could put 4 here. If I put 4 here, I'm going to tell you you have a magic number, and that's not going to work. So let's take advantage of size, because that's the same thing. That's the number of years I have. All right, so we got that. So this means then that years 1 through 4, okay, are going to be accessed and printed. So here I put a 1 the first time through. Collected year minus 1. Is this right? So if I want to do the first year, collected needs to be subscripted at year minus 1. 1 minus 1 is 0, and that would work perfect. Okay, and then I come back up and I say, is year less than or equal to size? Well, year is still 1. This is the prime. The thing I don't have here is the update of the loop control variable. So I need to do year equals year plus 1. Oops. And this is my update of the loop control variable. I will say this in your feedback. I will say you forgot to update, you forgot to prime. This is what I'm concentrating on here. And now I'd update and I keep going. So I would do year 1, year 2, year 3, year 4. When it's 4, I still come in because it's equal to 4, and then I bounce out. So that's us debugging that. Hopefully that helps you with that situation, okay? That's us using the arrays. Now, the next way we could use an array is search through the arrays. And this is in the book, but I just want to go through it a little bit here to help us understand what's going on. As, again, the subscripts, okay? So I have my declarations. And let's just get into the meat of this and find out how some of these are used, and then go back up and see what's happening. What my practice is, I always have an empty box here as I start to code, and or even in the flow chart. And as I start putting down variables I know I need, I go back up here and make sure that I declare them appropriate once I find a need for them, okay? And also when I'm looking at code, I don't spend too much time in here until I find them down here and I see what were they, what did I intend for them to be, and then I go back up. So that's what I'm going to do. What we're trying to do here is there is a customer order that comes in, just one customer order. And I want to check if whatever they ordered was actually a valid item in my store, okay? So I'm going to end up using a loop to search through all of the items that I have that I can sell and see if what the customer ordered is present in the loop. That's search, or in the array, excuse me, that's searching the array. So what I'm going to do is I have an array that contains all of the different items that I have available to sell. That's related, so that makes a really nice array. So this here is, they're going to be numbers. It's a constant because these numbers never change. I don't go and I don't modify them down here in my program at all. I come in with these numbers. Maybe I add another item to my store later, but I add it up here. I'm not doing any calculations or any modifications to them, so that makes a good constant. That's why they are all caps in the array name. Now the size is 6. I have 1, 2, 3, 4, 5, 6 items in my array, 6 items that I can sell, okay? So I'm going to input the name, the address of my customer, the item, and the quantity. Right now, all I'm going to be messing around with is determining if the item they ordered is in my store. And the way it's in my store is I have it in this array of valid items. So I'm going to start my loop, all right? I'm going to prime it with what is called sub. Sub here they're using to represent subscript, okay? So I'm going to start at 0 because remember my arrays are indexed starting at 0. And as long as the index is less than the size, 6, okay? Now, it's not less than or equal to size because I don't have a subscript of 6. Let's go all the way back here. My subscript is always 1 less than the size. That's the maximum subscript. So if I go and I do it equal to the size, I'm going to find out I don't have an ename subscript 3. I have an ename subscript 1 less than. So let's see how we can represent that. If I just say less than size, when I come through here, I'm going to stop when it equals 6. I'm going to let it go through with 5, which is a subscript that's legal in my array, but I'm going to stop when it equals 6. So this is a good thing to think about when I'm testing to stop going through an array, and I want to stop when I have reached the end of the array. So I'm starting at 0. It's definitely less than the array, and I'm going to come in here, and this is a test. So this is where I'm going to look at, is the item they gave me, which I read in here, equal to the valid item sub. So here is my array, valid item, and I'm doing the subscript at 0, which is the first location. Is the item equal to the very first item in my array? Let's see what my very first item in my array is. 106. Okay? If what they put in was 106, then what I'm going to do is say, oh, I found it. Okay? I'm going to use a flag here and say, I found it. And then I'm going to end up incrementing this subscript by 1. This is my loop control. And I'm going to come back up here and test. So now I have subscript is 1. Is it less than size? Yep. And I come in here. Well, let's say that I didn't find it. Okay? Let's say I have it as 688. So I'm now at subscript 1, which is the second location, 108. All right? So the item is 688 and I'm at 108. Nope. So I'm going to go and update the subscript again and come around. So what happens here is what you should notice is when I find it, I set the flag to found it. So this is a Boolean flag. Now I can go back up here and say the string found it is starts and it's initialized as no. I did not find it. Okay, so when I come in here, I'm going to change it to yes, only if I found it. This search is called a linear search because I'm actually starting at the very first location and I'm going to go to the very end. And it doesn't matter whether I found it or not, I'm going to still keep searching. So no matter what happens in the search, whether I find it or not, I'm going to continue to search. So a linear search goes from the beginning to end no matter what happens, okay? So that's my search. Say I got to the very end and I did find it at 688 and I flipped the flag. And I'm coming down here and I'm jumping out of my loop and now I'm saying, did I find it or not? I'm testing the flag. I could have gone all the way through this loop and I could have had 999 as the item that got read in, and it's not anywhere in my valid items, so I would have never come over here and reset this flag accordingly. I would have just searched through and found it would have stayed at no. So found it would have been no, and I would have wrote message no, which is item was not found. If I do find it, I write message yes. So this is searching an array. This is also helps us look at this, the indexing or the subscripting and the size, okay, gives us a little bit of a hint there. So let's talk about something else now. We know how to use one array, and you can only have one value. It can only represent one thing, like valid item that we just did. We had all of the different items that were valid in our store, and we indexed them. The first item is indexed at 0. The second item, 108, is indexed at 1. The size is 6, 1, 2, 3, 4, 5, 6. But the last item is not 6. It's one less than the size. Okay? So again, that's just repetition so we can get those in, because it really is important in how we access and work with arrays. Now, I would like to not only know the item number, but I would like to add the price. I would like to know that this item number is 50 cents, 59 cents, sorry. That item number 106 sells for 59 cents. Item number 108 sells for 99 cents. And I can do that with something called parallel arrays. What I'm doing is I'm setting two arrays up. One's going to hold the item number, and one's going to hold the price for the item number that's located at the same location in the other array. These subscripts now are what relates these two arrays. I have an array for the item number, and I have an array for the price. What I do is when I say price at subscript 0, I'm actually referring to the price at subscript 0 for the valid item. It's the indexes that link these two. Okay, this is how they are logically related. All right, so let's play with these a little bit more. Now I have two arrays, and the relationship is set by the subscript. So let's take that same scenario, all right? And what we want to do now is I would like to input an item number. We're inputting a little less than we did before. And I also chopped this. There's a lot more declarations up there, but these are the ones that we care about. Okay, I want to find out, and I want to read an item in, and I want to say how many of those items am I ordering. And what I would like to do is calculate the total, the price for all of those items. So if I ordered 106, now this is going to be a math test. I want 7 of them, all right? The price that I need to charge the customer is 7 times 59 cents, all right? That would be the price. And what I have to do is first find the location in the valid item array so I can find the price in the price array by using the same location. So let's see how that goes. I'm going to input just an item and the quantity. So I'm going to put in 106 and I'm going to put 7. This does not change. I have the subscript. I have to find out if it's legal first. So this is the same. I'm testing if it is still within the range of my array. And if it is, first thing I'm going to do is say, is it legal? And if it's legal, my flag is still set. Now notice what I can do. I can sit there and say the price, right, is located at the array, in the array valid price at the same subscript I'm currently at where I found the valid item. So I'm using the same subscript and I'm pulling out the price for that. This is new. This is the same. I'm going to go do a linear search, so I'm going to keep going even if I found it. okay, until I'm done searching the entire array, until I've gotten all of my items. Now what I do is if I found it, if I don't, I tell you about it, but if I found it, I'm going to still say I found it. And now what I want to calculate is I want to say, this is just a little bit of a heading. I'm going to output, there is 7 at the price. I got the price from over here. So the price was 59. I put that in price. Each, and then I'm going to output that I'm going to say that I'm going to say quantity times price is going to be the total. So quantity is 7 times the price, which I got from looking here, using that sub, pulled out that. And then that's what gets outputted. So you can see that parallel arrays are linked by the subscript. Okay. Now, I talked about the found it, right? And I also said, well, this is a linear search that we were working with previously, and I'm going to go no matter what. I'm going to keep going in our previous test, but this cleans this up a little bit, makes it a little bit more efficient. We know that I'm going to go all the way to the beginning and stop when I hit all of the elements in my array. But now what I would like to do is jump out of here, okay, when I find it. So I only want to come into this loop when found it still equals no. So if I haven't found it yet, it means now I'm going to keep going through. But what if I found it? I'm going to upgrade the subscript, come in. The subscript could still be legal, but if I found it, don't keep going through the array. You found it, you're done. So this is one way to be more efficient than our linear search. Have a flag, which we had, all right, and take advantage of it and use it in my test. In my test. All right. Now, there's another concept that we introduce here called a two-dimensional array. All right. It's one array that has the ability to, let me do this. I want to do something real quick so we don't. This is what we've been talking about so far. We have an array, right? And it has rows. It has indexes, 0, 1, and 2. And we would have put prices in here or indexes in here or people's names in here. That's all we have so far. But what we can do is extend this dimensions to being a 2D array. So not only do I have a row, I have columns. The Blackboard uses this as a way of doing a seating chart, okay? If I'm in the first row, first seat, first column, that would be me, okay? And I could have somebody else they're still in the first row, but they're in the second column. This, if you think back, if you've ever worked in Excel, this is exactly what you see in Excel. You have columns and rows. And where a column and a row meet is the value, okay? So when I say that again, when a column and a row meet, there's the value. So when a column and a row meet, so I have 2 indexes. This is my row index, just like that. This is my column index, just like that. And when they meet, that's the value. So array row 0, column 0 has the value A in it. Column 0, row 0 has the value A. Now to define this, I would say the array has 3 rows and 3 columns, okay? Then I get this situation. Here's my 3 columns and here's my 3 rows. And this is how I could index and get into them. All right? So that is a two-dimensional array. Now there's some place we use a two-dimensional array frequently when we were kids, and that's the multiplication table. all right? So just look at this, ignore that blue right now. Just look at this. This is the multiplication table, all right? 1, these are the columns, and these are the rows. And what we would do is, this is the multiplication symbol. We would say 1 times 1 is 1. 1 times 2 is 2. 1 times 3 is 3, all right? So we could, if we wanted to, recreate this, and we are going to in just a few minutes. What this is showing, and there is this inside Blackboard, and I just want to talk about it, not implement it or go any further about the fact. I just want to say what I want to I want to say something about it. When you learn your multiplications, you learn let's take this, 2 times 3 times 2 is 6. But 2 times 3 was also 6. So you didn't have to learn all 100 numbers here. You only had to learn half of the table, because what we knew was it didn't matter whether I said 1 times 2 or 2 times 1. You got the same number. And what this represents is a mirrored array. It means that in reality, there is a diagonal that exists in this table. It's right along here in this white. The items on the blue are the exact same things as the yellow. The only difference is how you subscript them. So we'll use this arrow. It's row 8, okay? And it's column 2 is 16. So if I wanted to get to that the way I said it, I would do row 8, column 2. But notice I could say row 2, column 8 is the same number. All I've switched is the subscripts. I put what used to be the column as the row, what used to be the row as the column. That's all that's being represented here. And that when you're sitting here trying to figure out where is the diagonal is, I want to get right there, let me in. The diagonal is where the array row equals the array column. Okay, well, let me get rid of that. That's distracting. When the column equals the row, column equals row, column equals row, be fair to you guys. That's the diagonal. Column and row are equal. So that was what the information was. But what's really interesting, and what I do want to do, is go on and let's just generate this multiplication table. What you could do is generate it, understanding it's a mirrored situation, but that's out of the scope of what we want to do. Okay, there are more advanced classes that you can work into that, but let's not do that. Let's just do the multiplication table. All of these, all 10 columns and all 10 rows. And how I want to do it is I'm just going to show you what I've already got done. Let me find it. I got it. So we're just going to talk through this. This is pseudocode with tons of comments. So hopefully it will help you also understand how to do this with a two-dimensional array. All right, remember, here's all my declarations. Let's just hang out and ignore those for a minute, okay? I need to put the values in the multiplication table, and then I'm going to print them. Now, I have rows and I have columns. So, first thing I want to deal with is the row, right? Let me get my little picture up here so we keep coming back to that. I'm going to do So I want to get a hold of, sorry about that. Come on back. There we go. We're going to go by row first. I'm going to go and say I'm going to work on row 1. When I'm in row 1, I have to deal with this column, this column, this column, this column. See my pattern? This column, this column. Get the pattern yet? So I'm going to end up, I'm always in row 1, but I have to walk along the different columns. So I'm going to stay in row 1 and increment along and figure out what values go in the columns. Then, when I'm done with the column, I'm going to go down, I'm going to do the next row. So I'm going to increment and go to row 2. And I have to start the columns all over again. I have to do this value, this value, this value, this value. Okay? So thinking about that, I'm going to do row, and then when I'm working on a row, I'm going to be implementing the different columns. So I'm going to have to increment to go across. When I'm done with the column, I'm going to increment the row, start the columns all over again with 0 and increment along. So let's see how that's done in some pseudocode using two-dimensional arrays. So, as I said, I'm going to start with the row, and I'm going to use this row as a subscript for my array, so it needs to start at 0. Okay? So I'm priming my loop control variable for the row loop. So while row is less than the table size. So let's figure out what this is. The table size up here is 10. I have 10 rows and 10 columns. Okay? So what I did was I set up, knowing I have 10 rows and 10 columns, I'm initializing this array to be two-dimensionals, a 10 by 10. All right? So I have a 10 by 10 array. Let's go into C. So as long as I'm less than 10, I start at 0. Okay? I'm ready to start my columns now. So I'm going to index from 0 to 9 and insert all the values in the row. So to insert the values in the row, I have to now deal with all those columns. So I'm going to start column at 0, and I'm going to do another loop. So this is my loop control for my columns loop. This is an example of a nested loop. We haven't used these frequently, but this is a real good example, and so I'm trying to double dip here, showing you nested loops and also the 2D array. So same thing, as long as I don't get larger than the table size, okay, less than table size, so I'm going from index 0 through 9 because I started here, I'm going to end here. Now I'm going to put the values in each column for that particular row. So I'm in row 0, I'm going to start at column 0. Where is that? Row 0, column 0 is right here. What goes in there? Well, the row started at 0 and the column started at 0, but my math starts at 1. So my row and column is always 1 less than the number I'm actually needing to do the multiplication. So what I'm going to do is I'm going to add 1 to the row, add 1 to the column, and then I'm going to times them together. So initially it'll be 1 times 1. That's going to be the value. I set this apart here just to help with being more explicit with what we're doing. So now, in the table though, in row 0, column 0, I'm going to put the value. So 1 times 1 is 1, so I put 1 in the location 0, 0. Row 0, column 0 now has a 1. Okay, I'm nesting my loops. Remember, I need to go all the way along and do the next column. So I'm going to increment my column, my loop control variable, come right back up to the top. As long as it's less than 10, so I go from 0 to 9, I do it again. So my row is still 0, so I want to multiply 1, but my column now is 1, so I want it to be 2, so I add 2. So 1 times 2 is 2. I place 2 in row 0, column 2. Row 0, oh no, excuse me, column 1, column 1, column 1. Didn't mean to do that to you. Row 0, column 1. This was column 0. This is column 1. And I'm going to continue that until I get all the way to the end and I got all of my values in. So this would be column 9 right here, column 9, row 0. So I got it in, and now I am no longer less than the table, so I'm coming out of this loop. I'm done with that inside loop. So what I want to do, remember what I said, let's go to the next row. So let's go to this row. So I have to increment my row. I'm updating the loop control variable for this while loop, which now has me start on this row, which I need to start the columns all over again. So I go to column 0, which would let me work right here in this row. And I do the same thing over and over again, okay? So that is an important little lesson for 2D arrays, but almost as important is the fact that I nested my loops. Let's go real quick and look at printing this stuff out, okay? What I want to do is I need these labels, right? And I need all of the columns to be printed first before all these values print. So what I've done here is I'm going to end up printing just the column out, this header. This is column 0 as far as the subscript goes, but the number that I want to print is a 1. So what I do is I output column plus 1. Now what this is just, let's go back up here. I just made a string to tab these things over. This is just a language specific kind of situation. So I had some gaps between these. That's all. You don't even have to do this. If you don't have that when you were thinking about that, no biggie. But I just wanted to throw that in there. Then I was going to do a tab and then print the column plus 1, index plus 1. So index 0 plus 1, I'm going to print that number 1 there. This is column indexed at 1 plus 1 gives me that number there. All I did was print the headers. I got the headers over there. Now what I want to do is print out all of this stuff, including the label for the row number. So I'm kind of in the same situation with the labels, right, as I was here, the row. So I'm going to start at the index for the row at 0, so I start here. And I'm going to output first the row index plus 1, so I get that little number right there. Now what I want to do is my inner loop to get all of these values from the different columns printed. Very much like what we did when we were calculating it. We were going through the columns from 0 to the end of the table, and here I put the numbers in. Here I'm going to get the numbers out. And all I did was this tab. Remember that tab bar? I just end up output whatever is in column, row, the table row and column. Row right now is 0, so 0. First time I'm in here, I need to open this up just a bit, okay? I didn't do something. Shame on me. If you notice, right here, when I started this inner loop, I primed the loop control variable. I didn't do it. So column equals 0 here. See? Prime loop control variable. 25 years of programming and you still blow it. So you always gotta make mistakes. We just go with it. So now I'm gonna go. Now I have a value in column, it's 0. I have a value in row, it's 0. So I'm gonna put that value right there in my table. And then I'm gonna update, go to the next column, continue looping till I reach the end of all my columns. Now that loop is done. I'm going to go and update my loop control for my outer, go down to the next row, start my columns all over again, just like I did before. So that's how you can create a multiplication table. All right? Pretty much between these two that's just declarations. So I'll leave that there for you a couple seconds. All right? As I go and get things organized, moving that over. And that concludes a little bit of basics for arrays, a little bit of searching, linear searching, and then we ended up putting a flag in there to make it a little bit cleaner, to be more efficient. We looked at parallel arrays, and we looked at 2D arrays. The next topic snippet, if you want to follow along, is I'm going to go into the assignment that's called Chapter 5, and we're going to just look at how we would outline setting that up. So watch for that one coming up soon.